Example 1.4.3. A particle of mass 2 kilograms is sliding down a rough slope inclined at 30 degrees to the horizontal. Given that the acceleration of the particle is 1 meters per second, find the coefficient of friction between the particle and the slope. So the coefficient of friction, that is what we use the symbol mu to represent. Let's start with a diagram. So here's the slope. Here's my particle on that slope with a mass of 2 kilograms. The slope is inclined at 30 degrees to the horizontal. Always look carefully. Sometimes it'll say vertical. This case it's the horizontal. The acceleration of the particle is 1 meters per second, and we've been told it's sliding down the slope. So I'm going to add that to my diagram as well. We've got to find mu. So let's put all the missing forces on. Normal reaction force perpendicular to the slope. The weight of the particle, which will be 2 times gravity, which will be vertical. And because it's sliding down the slope, friction will be acting up the slope. So that's it. Those are the only forces. It's the component of the weight which acts parallel to the slope that is causing the particle to slide down. So just because the question says it's sliding down, don't go making up a new force pushing it down. There isn't one. It's its weight that is causing it to slide down the slope. So let's find mu. We're going to use the equation F max equals mu times R. It's mu that we want to find, so therefore we need to find F max and we need to find R as well. So I'm going to resolve, or do Newton's second law, same thing. Perpendicular to the slope. Here we go, I've got R pointing in that direction. Friction is perpendicular to this direction, so won't be included. The weight makes an angle of 30 degrees with my direction, so it will be cos of 30 degrees times the weight. And perpendicular to the slope, there is no acceleration. Very important, you put this equal to 0. It depends on what direction you're working in. If you're working parallel to the slope, then the acceleration is 1. But if you're working perpendicular to the slope, there is no acceleration. So rearranging this, R is 2g cos 30. Now cos 30 is root 3 over 2. So this is root 3 times g. I'm going to leave it like that rather than turn it into a decimal. That's R. Now we need to know friction. Because it's sliding down, then we know it's definitely moving. Therefore, friction is at its maximum value. Once motion starts to take place, friction keeps trying to stop it moving. So once it's reached its maximum value, it stays there. So Newton's second, now I'm going to work. I've got a decision to make, either up the slope or down the slope. I'm going to go down the slope because the acceleration is down the slope. If you decide to go up the slope, you'll get all the same terms as me, just opposite signs. So I'm going down the slope. I've got minus friction. Friction is already in my direction, it's just pointing the opposite way, hence the minus. And then the weight, I need to turn that through 60 degrees. So the angle between the weight and my direction is 60. So I'm going to go with cos. Well, it's always cos of the angle between the force and the direction. So 2g cos 60. The reaction force won't be included in this direction because it's perpendicular to this direction. So that's the resultant force equals the mass times the acceleration. And because I chose to work down the slope, the acceleration is positive 1. If you worked up the slope, you'd use an acceleration of negative 1. So by rearranging this and simplifying it, 2g cos 60, well cos 60 is a half, so that's just 1g. And then I'm going to take away 2 from both sides and add friction to both sides. So friction is g take away 2. And actually, please remember that in this case, friction has reached its maximum value. So mu, if we go back to the earlier equation, is F max divided by R. So that's G take away 2 divided by root 3G, which when you put it into a calculator, you get 0.46 to 2 significant figures. Mu does not have any units. So the answer there is just 0.46. If you gave the answer to 3 significant figures, you'd get the right mark. It would be 0.460 if you gave 3 significant figures. But because we've used G in the calculation, if you give more than 3 significant figures in the exam, you will lose the final accuracy mark. So there we go. Once again, mu does not have any units. It's because it's a force divided by a force. F max is a force, R is a force, therefore the units cancel out. So mu does not have any units. And that completes example 1.4.3.